Namaste, everybody, and welcome to the third webinar of 2024 Knowledge Series. We have a great privilege to have Dr. Vanishri Bhat talking about constructive geometry in ancient India today. Dr. Vanishri Bhat recently joined as an assistant professor at Chanakya University, Bangalore, in the School for Arts, Humanities, and Social Sciences. After graduating in science, she pursued an MA in Sanskrit, specializing in Shabdabodh and language technology from Rashtriya Sanskrit Vidyapith, Tirupati. Further, she went on to complete PhD in the Cell for Indian Science and Technology in Sanskrit, Department for Humanities and Social Sciences, IIT Bombay, under the guidance of Professor K. Ramasubramanian. She also has a one-year postdoctorate from Purna Prajna's Sanshodhana Mandiram, Bangalore. She has more than 8 years of research experience in the field of history of Indian mathematics and astronomy. She has presented research papers in national and international seminars and published articles in journals like Ganita Bharati to her credit. Having come from a Sanskrit traditional family background, she has taught the Sanskrit language in various reputed degree colleges. She was one of the instructors for an online diploma in Bharatiya Ganit offered by the National Sanskrit University, Tirupati. Welcome, Vanishri, and thank you again for joining us today in spite of your busy schedule and doing this webinar on a very interesting topic of constructive geometry in ancient India. Over to Vanishri.
Thank you, Swatiji, and namaste to everyone. I'm really humbled and thank you for giving me this great opportunity to present on the very famous platform, IAVM. Thank you very much for giving me again the opportunity here. So the topic that I have chosen is constructive geometry in ancient India. Before I go forward, I'll just briefly tell you what I'm going to cover in this lecture. I'll starting with the introduction. I'll discuss on Sulbasutra as a constructive geometry. Then I will move on to discuss about Sulbasutra as a branch of Kalpasutra, etymology of Sulbasutra, etc. Then I'll discuss the different tools determining the east-west line using Shanku. Then we'll also see construction of various geometrical figures like squares, trapezium, circles, this kind of geometrical structures. Construction of these structures we will see using sutras. Then I'll move on to discuss about converting geometrical shapes, but preserving areas, that is area preserving transformations. Then we will also see the famous theorem, the theorem of the square of the diagonal, and last but the least, the rational right angle triangle, followed by the conclusion. So this is what I'm going to discuss with you. So what is the constructive geometry? Mitchell Benson, in his research article, says that constructive geometry has two perspectives, as he says, referring to the constructive. One is geometrical constructions with straight edge and compass. On the other hand, constructive may suggest the use of intuitionistic logic. Now, let us see how or why in India, geometry got developed. One of the prime occupations of Vedic people, even around 1000 BCE, was performing yajnas. There in Yajusha Jyotisham, it says Vedahi yajnartam abhipravartaha kalanupurvya vihitascha yajnaha tasmadidam kala vidhana shastram yo jyotisham vedasa veda yajnan. Vedas are ordained to perform yajnas. The science of time, astronomy, exists to fix suitable times for sacrifices, and he who knows astronomy knows the sacrifices. So performing yajna was an important part of culture. Vasante, Brahmanam, Upaniyita, Grishme, Rajanyam, Sharadi, Vaishyam, Yajno vai Shreshtatamam karma, says the Shatapatha Brahmana. That means performing yajnas are superior act. So that's how yajna was given that much preference. So since I have taken the word yajna, let us briefly see what the type of yajnas are. There are different classifications of Vedic yajnas by various authorities, but in broad sense, they are divided according to the individual for himself. That is, Griksha yajnas performed for community and for the national importance. Community purpose, Shrauta yajnas and Rashtriya yajnas, which is which is for the national importance. For example, Griksha yajnas, they are like domestic rituals. These are very simple and involve oblations of boiled rice, also called as Paka yajnas. Here are the examples: Anupasana Homa, Vaishwadeva, Parvana, which is performed monthly. Similarly, Shauta yajnas are divided into two. They are Havir yajna and Soma yajna. So Havir yajna, they are in the Havir yajna, oblations are clarified butter and preparations of rice, samit, etc. Soma yajnas, where they offer Soma rasa. See, just I'll briefly go through the Havir yajna, where Agnihotram, Chaturmasyani and Sautramani. Just note this Sautramani because I'm going to discuss about the construction briefly later. Just note it down, Sautramani. And these are all Soma yajnas, where oblations are offered through Soma rasa. Vajapeya, these are all some examples. Similarly, Rashtriya yajnas are performed in the interest of national. They are performed in national level. For example, usually they are performed by kings. For example, Ashwamedha Yaga, which is so famous, that is performed by an emperor to gain the sovereignty. Now, this all yagas mentioned in Vedas are performed in the altars prescribed in particular sizes and shapes. The need to have a separate manuals for referring rules and regulations to constructing altars, Vedic people composed class text called Sulbasutras. For the Sulbasutras. Knowledge is divided into para and apara. Athapara yatha yadaksharam adhigamyate. Tada aksharam adhigamyate. That means by which we attain the Brahma, that is called para. And another is apara, where apara contains Vedas and Upavedas. Vedas are, again, it is known that Rig Veda, Yajurveda, Samaveda and Atharvana Veda. Then again, Veda has Vedangas, auxiliary to Vedas. That is Shiksha, Vyakaranam, Chandas, Nirukta, Jyotisha and Kalpa. Here, the Kalpasutras, again, they are four: Shrautasutram, Grakshasutram, Dharmasutram and Shulbasutram. I'll not go into detail, but just in brief, I will tell you the definition of Kalpa. That is Kalpyate, Vidhiyate, Asau. That means ordered, ordained. Rules and regulations are ordained by this. Sutram, as it is known that they are aphorisms. Literally, it is a string or thread. We know Vakarana Sutra, Yoga Sutra, Dharma Sutra, and even Vedic mathematics. They are all kind of sutras, right? Small definition for sutra goes like this: how sutra should be. Alpaksharam asandigdham saravat vishwato mukham astobham anavadyam cha sutram sutra vido viduhu. Alpaksharam, it should be concise, asandigdham, without doubts, or no ambiguity. Saravat, it should be meaningful. Vishwato mukham, when you construct sutra, it should be universal. Astobham. Astobham here, it has two meanings. Astobham means in Veda, they have this kind of sounds, aksharas. Sutra should be devoid of that that aksharas or those sounds. Because when you see Sulbasutra compared with Vedas, you don't have this kind of sounds in between. Kind of sounds, they are not there. Anavadyam. Anavadyam cha sutram sutra vido viduho. It should be refutable. There should be no objections. That should be the sutra. This is the definition of sutra. Now these are all in the form of sutras. Shrauta Sutram, Graksha Sutram, Kalpasutras are divided like this. Shrauta Sutram, Graksha, Dharma, and Shulba. Shrauta Sutram are written for rituals associated with societal welfare. Where Graksha Sutram, there you'll see rules and regulations for rituals related to household. And then Dharma Sutram, where rules and regulations are related to duties and general code of conduct. Now, Sulbasutram, that where rules and regulations for constructing geometrical shapes which were required for fire altars. So coming to the etymology of Shulba, the root word for Shulba is Shulbamani, to measure. But again, it can be derived in the following manners. Shulbanam, that is Shulbaha, the act of measuring. If you derive Shulbyate iti Shulbaha, that will be the result of measuring. That is called Karma Vitpatti. And if you derive Shulbayatyanena iti Shulbaha, that refers to the instrument of measuring. That is Rajju. The Rajju means the cord. So whole Shulba Shastra is also sometimes referred as Rajju Shastra because there the main tool is a Rajju, rope. Using rope, you measure, you construct the whole altar. Here, usually Bhava Yutpatti has been employed and hence Shulbanam is taken, the act of measuring. An expert in the science of Shulba was called as Agnichit, constructor of the Agni, because he constructs one by one the chitis and then he performs yajna. Here, there are also Shulba with Shulba Pariprachaka. Shulba with means the one who knows Shulba properly. Shulba Pariprachaka, the one who inquires, asks about the rules and regulations of the constructing fire altars. Okay, coming to, I have already shown what are yajnas in broad sense. Now coming to Kamya, Nitya and Kamya Agnis. In Vedic sacrifices, whatever you have seen earlier, the yajnas, they fall under either Nitya or Kamya Agnis. So what are these Nitya? Nitya means indispensable or obligatory, which are those yajnas to be performed by every Hindu without fail. Those are called Nityas. And coming to Kamya Agnis, those are performed with some motive of achieving special desires. For example, in Bodhayana Sutra, there is Athavai Bhavati Shena Chitam Chinmita Swargakama iti. One who yearns for heaven should construct the Shena Chiti. See, is the Shruti. So one who wants to attain the heaven, he can construct the Shena Chiti and then perform the Yajna. Similarly, Shena here is a word which is used, the altar is in the form of falcon. Shena Chiti is in the form of falcon, huge bird. Similarly, Kurmachitam Chinvita Yaha Kamayeta Brahmalokam Abhijayema iti Vijnayate. He who wishes, may I conquer the Brahmaloka, is to construct Kurmachiti. Kurma here means tortoise. The chiti is in the form of tortoise. So these are all Kamya Chitis, means if one has certain goal, then only he can perform these Kamya Chitis, Kamya Agnis. But Nitya Agnis are obligatory. Everyone has to perform. Here, the interesting thing is the sacrifices are constructed are constructed according to the strict injunctions of Shastras. So the shapes and sizes, they are to be perfect as they are said in Shastras, as they are ordained in Shastras. A slight irregularity from form and size of the altar will nullify the result, and sometimes even it might give the adverse effect. That's why they had to see that all these uh, geometrical figures, or they are to be perfect. Whatever it is ordained in the Shastra, it should be done in accordingly. Okay, this is example of sacrificial altar. This is example for Nityagni. Okay. There are three prime Nityagnis again are prime three. They are Garhapatya, Ahavaniya, and Dakshina. This is performed daily by Shrutis. This picture is taken from one of the famous Shrutis who resides in Gokarna, and he performs daily. Just observe this Nitya Agni, where you can see an altar which is in circle, which is Garhapatya, and then this is Ahavaniya, which is in the shape of square, and this is Dakshina, which is in the shape of semicircle. Now, the interesting thing is this Garhapatya and Ahavaniya, all of them, they have to have same area. The challenging thing is you have to construct the circle and square, these both of them having same area. They in Sulbasutra detail the procedure to construct circle to square and vice versa is given. I will deal with that in later. This is another picture where you can see Garhapatya, Ahavaniya, and Dakshina. Some geometrical shapes you are seeing here. See, this is the example for Kamya Agni. This is particular example for Somayaga, where you can see the shape of trapezium. And here you can see the same Garhapatya, Ahavaniya, and Dakshina. So it is very huge. Here the Somayaga is performed. Here you can see two carts are placed where carts are there, where Soma plants are placed. I'm just giving you the example how these geometrical structures in altars are done. Okay, now the altars, different chittis and then their prayojanas. Chittis means mound constructed of baked bricks. Chitti also means the root word chi. That means to arrange or to protect. Now, chittis are named after the shape of corresponding altars. Here you can see different chittis, different fire altars, which are named after the shape of the construction. There are different chittis, and also the result, as I said, that Kamya chittis are performed with having some desire in mind. For example, Kanka chitti, which is in the shape of heron, the desired result will be the prominence in the word. If someone wants to attain the heaven, he can perform Shena chitti, which is in the form of falcon. If someone wants to conquer the whole world, he can perform the Kurma Chitti, which is in the form of tortoise. The interesting thing, there are 10 chittis here mentioned. There are also some chittis where bricks are not needed. Only by some Veda mantras, they are assumed to be constructed and yajna is performed. That is Chandas Chitti. That is called Chandas Chitti, where bricks are not there, but Veda mantras are just recited there. So different chittis, the shape and desired results that I have mentioned here. I'll not again go through it, just for the example I have taken. So you can see here different shapes of, this is the Shena Chitti. Shena Chitti, these all chittis are, they have to have the area of 7.5 Purusha square. That you can construct the chiti, but the whole Shena, whole shape should be of 7.5 Purusha square. Purusha, again, I'll tell you later what the measurement of how much should be the measurement of Purusha. So these are different geometrical structures that you are seeing here. This is the Shena Chiti, this is the Kurma Chiti, this is called as Ratha Chakra Chiti, which is in the form of wheel. So you can see the circle, and here again the small bricks which are of again different shapes, square, triangles, and then yeah, there are different shapes which are shapes of bricks used in this constructing in this chittis. Now, just briefly discuss on the extent of Sulbasutras, how many Sulbasutras were there, how many are existing now. So far, there are 7 different Sulbasutras have been identified by scholars. Baudhayana Sulbasutra, which is the part of Krishna Yajurveda Taittiriya Samhita. Apastamba Sulbasutra, Krishna Yajurveda again. Varaha Sulbasutra, Krishna Yajurveda again. Katyayana, Manava, Maitrayana, Vadhula Sulbasutra. These are Sulbasutras, which are, sorry, here it should be 7. These are Sulbasutras identified by scholars. So, out of these Sulbasutras, Baudhayana Sulbasutra is considered to be most ancient one, prior to 800 BCE. And because first thing is it is very huge. Another thing is it presents a very systematic and detailed treatment of several topics that is skipped in later texts. Because it is already presented in Baudhayana Sutra, maybe they would have skipped in later Sulbasutras. Coming to the date of Sulbasutra, according to the famous historian T.A. Saraswati Amma, she says that based on her linguistic approach, she says that they are all pre-Pandyan and could be placed around 800 BCE. But if you see the concept and the practice, it seems that they are much earlier than the estimated dates of that is 800 BCE. For example, in Rig Veda, there is a mention of Garhapatya fire. Garhapatyena Satya Ratana Yajna Nirasi Devan Devayateja. There is also mention of 3 types of Agni in Rig Veda. Yajnasya Ketum Prathamam Purohitam Agnim Naras Trishadaste Samidhire. 3 types of Agnis are mentioned in Rig Veda. Similarly, Shena, the word Shena is found in Rig Veda. So that's how, not only that, scientific records through systematic survey of Vedic literature by Navaratnas Rajaram and David Frawley in their work Vedic Aryans, they say that Rigveda flourished on the banks of Saraswati. Rigvedic age must have ended much later than 3750 BC. Harappan civilization was continuation of Sutra period. Therefore, the post-Vedic Sutra literature containing the works of Baudhayana, Apastamba and Katyayana must have been in existence well before 2000 BCE. That's what they conclude. So that means, though we estimate that it would have been written in 800 BCE, definitely the concepts and the discussion were there in Veda. It was much earlier than estimated the date as 800 BCE. Now, if we see the topics that covered in Baudhayana, I have taken only Baudhayana. That's, I think, enough, because in all other Sulbasutra also they are almost the same. There are topics like the Rekhamana Paribhasha, units of line, linear measurements. Then you will see Chaturashra Karanopayaha, how to construct squares, rectangles, etc. There also you can see interesting things like obtaining the surds or theorem of the square of diagonal. Then also there are topics like transformation of geometrical figures, plan for different sacrificial grounds. Like that, you will also see how to choose the clay or sand in making bricks, because bricks were needed in order to construct the Chiti. Also, you will see the process of manufacturing bricks and different shapes, how to construct different chittis like Shena Chitti, Kurma Chitti, etc. These are all topics that are covered in Bodhayana Sutra. So similar topics, and these similar topics are covered in other Sulbasutras also, but not in that much detail which are given in Bodhayana Sutra. So this, coming to the geometrical knowledge that which we see in Sulbasutras. There are, as we saw, that Nityagnis are Garhapatya, which is in circle, Ahavaniya, which is in square, and then Dakshina, which is in semicircle. All they have to have one Vyayama, which is 96 angulas. The area, which should be 96 angulas. Now, if you want to construct these figures, these geometrical shapes, this, you have to have the knowledge of the following geometrical operations. What? When a given line, you have to construct a square on that straight line. Then the knowledge of circling a square and vice versa, where the knowledge of pi value is required, that is also needed, that is also required. The knowledge of, where you can see pi value estimated to be 3.0885, and this pi value, the expression is given in verse format in Sulbasutra. We will discuss it later. Also, the knowledge of doubling a circle, which involves the evaluation of square root, that is also known. So, nice sutra has been given in order to, for the expression of root 2. Pramanam tritiyena vardhayit tat chaturthena atma chatustrimshonena savisheshaha. Here, this savishesha is the term, technical term given for root 2. We will discuss it again when we are discussing how to convert square to circle and vice versa. So this also gives the proposition that the area of the square on the diagonal of a square is double the area of that square. Okay. See, not only in Sulbasutra, if we see Vedas, there itself we have the idea that Vedic period also possessed geometrical knowledge. Anyway, mention of 3 Agnis are there in Veda. The evidence in Rig Veda that the form measured and is divided into equal areas. The person who used to measure was called as Ribhas. It is needless to point out that in order to measure and distribute the land, knowledge of geometry is imperative. We also see the word Akshnya as a hypotenuse of a right angle triangle mentioned in Taittiriya Samhita. Shataprata Brahmana also describes the detailed procedure to construct Mahavedi, which presupposes the knowledge of so-called Pythagoras theorem and rational right angle triangle. We also see there are different chariots, different types of chariots mentioned in the Rig Veda. For example, the chariot which is described is as a triangular having 3 wheels at 3 seats. Tribandhurena, Trivrita, Rathena, Trichakrena, Suvrita. We also see the great number of varieties of chariots are prepared by that time. Not only that, there is a mention of construction of concentric circles with desired diameters in Rig Veda. We see different geometrical terms like Trirashri, Chaturashri, Dashabhuji, Tribhuji. Ashra means the side. Bhuja, side in Atharva Veda. So even during Vedic period, the knowledge of geometry developed considerably, which we find later in Sulbasutras. Already it was developed in Veda. In Vedas, these concepts were there, but Sulbasutras, they wrote it separately as manuals. Not only just advanced geometry, but it's quite evident that arithmetic also seen embedded in Shulba. In fact, knowledge of geometry was predominated by arithmetic knowledge. Here, Sulbasutra, dealing with fractions, if we see dealing with fractions and operations with fractions, it really puts us in awe. Familiarity of fractions can be seen while the construction of bricks for the fire altars. There are terms like Chaturbhagona, Chaturbhaga Ona, 1/4 minus 1, Ardhashtama, Ardha minus minus 8, which is Ardha, which is 7.5, which is called as Ardha Ashtama. Then Ardha Navama, 9 minus half, which is 8.5, Ardha Navama. Then this one, Chaturtha Savishesha Ardha. I have already briefly mentioned about Savishesha, right? This is Savishesha. Root 2 is Savishesha. Chaturtha Savishesha Ardha. Root 2, Chaturtha means 1/4 of root 2, 1/4 of Savishesha, and Ardha, half of the result. Chaturtha Savishesha Ardha. Then again, Chaturtha Savishesha Saptama. Chaturtha Savishesha, this is 1/4 of root 2 and Saptama, 1/7 of that result. That is called as Chaturtha Savishesha Saptama. These are beautiful technical words, I think they have used in Sulbasutras, but with fractions. So also we can see divisions of fractions, calculations for squaring of fractions in Sulbasutras. The interesting thing is dividing a given line into any fraction of its length. Okay, as I told, it is a Sulbasutra rope geometry. Okay, you have a rope with you, then it is to be divided into fractions. For example, you have a rope, divide a line of length 2x. You have a rope of 2x, and that is to be divided into 3/4 and 5/4. And another example is if you have a line and you have to divide, you have a rope with rope of 1.5x, and you have to divide into 5/12x and 13/12x. It's not actually a simple thing when if you are given a rope and you have to divide it into fractions. Also, we see in Apastamba, there is a description of construction of Sautramani Vedi, whose area should be 1/3 of Mahavedi. See here, if you see the diagram, this is the Mahavedi. Okay. Now you have to construct a Sautramani Vedi, which is 1/3 of this Mahavedi. Again, you have to perform yajna in the area of 1/3 of this Sautramani Vedi. So you need the knowledge of root 3 also. So this is how there are different. There are sutras even for root 2 and root 3. I will go through it later. Before that, I wanted to just familiarize with some instruments that are used in Sulbasutras. Rajju, which is a cord or rope with markings on it and specified lengths. Rajju is a rope. That's why it is called as Rajju Shastra. Shanku is a gnomon which is 12 angulas and divided into 12 equal parts. Then again Venu, that is a bamboo pole with a length equivalent to height of Yajamana. Yajamana means the sacrificer. Height of Yajamana with a lifted hand, raised hand. Bamboo should be of that height. Then Shamya, it's a wooden yoke, pin of length 36 angulam. Now, here is the actual part of constructions of different geometrical shapes. First, I will take determining the east-west line, because whenever the yagas are performed, first they had to determine the east-west direction. There, they start with the procedure, how to determine the east-west line. The sutra goes like this. Same Shankum Nikhaya, Shanku Sammitaya Rajwa Mandalam Parilikhya, Yatra Lekhayoho Shankvagra Chaya Nipatati, Tatra Shanku Nihanti Sa Prachi. So, fixing a pin or gnomon on level ground and drawing a circle with a cord measured by the gnomon, he fixes at the points on the line of the circumference where the shadow of the tip of the gnomon falls. Here, if you see in the figure, OX is the gnomon, OA is the foreground shadow, and OB is the afternoon shadow. This is how they used to determine east-west direction, east-west line. Now, once you determine the east-west line, you have to determine the north-south line by bisecting that line. Again, the procedure has been given. There are two commonly employed methods, which are Matsya Chitranam, another is Rajwabhyasanam. Matsya Chitranam we have learned in our school days. Rajwabhyasanam is folding the cord. Matsya Chitranam is by drawing a fish figure. Rajwabhyasanam is by folding the cord. So for Rajwabhyasanam, sutra goes like this. Tadanantaram Rajwabhyasya Pashau Kritva Shankvoho Pasho Pratimucha Dakshinayamya Madhye Shankum Nihanti Evam Uttarataha Sodichi. Here you have east-west line determined. Now you have to bisect the line in order to get north-south line. So after determining the east-west line, doubling the rope, you have to take the rope, double it, and making ties at their ends. One fixes the ties on the pins at west and east, stretches the cord to the south. Okay, here you have to stretch the cord to the south and strike the pin at the middle. Similarly to the north, that is called Udeshi, that is north-south line. This is how they step by step. Okay, you can see even the description. It is like the construction is step-by-step procedure. Now, once you determine the east-west line, now let us see how to construct a square on a given line. There are different methods which are prescribed in Sulbasutras. I will take a few of them. The first one is, the sutra is like this. Yavan yajamana urdabahus tavad antarale venos chidre karoti madhye tritiyam. So you have to take a bamboo which is the length of Purusha. Purusha means Yajamana, the sacrificer, with uplifted hand. Okay. Take AB. Let us take that AB is the bamboo, which is the measure of one Purusha. There you have to make a third hole in the middle. Okay. Then Unmuchya Purvasmad Aparasmin Pratimuchya Dakshina Pratyek Parilekhed Antat. What you have to do is fix the bamboo at point A, then release at B and draw an arc. Again, you have to fix the bamboo at point B, release the other end, and then draw an arc here. Okay. Here is the intersection point OO dash. So after placing, you have to place the bamboo on OO dash. That is the perpendicular line. Then you have to draw a parallel line tangent. Okay, here. This is how you can construct a square which is equal to the one Purusha square. This is one method. This is using a bamboo. There is a method which is using a cord. So I'll not go through the sutra as such. I will just briefly tell you how it is constructed. You can see here the beautiful geometrical figure to construct a square. Chaturashram chikirsham yavat chikirshe tavatim rajjum ubhayataha prasham kritva. This is how it goes on. If you want to construct a square, chaturashra square, yavat chikirshet, how much ever you want to the side of the square you want to construct, that much length you have to take, that much length of the rope that you have to take. Okay. Now, Madhya Lakshanam Karoti, you have to mark a point at middle. Take a rope, okay, mark at the middle. Now, we know that east-west line is already constructed. Okay. Take a rope, mark at the middle and place it on east-west line. Fix it at O. Okay. Release at one end and draw this circle, this blue circle which is seen. After that, release the rope, just tie it at east point. Here you have fixed the middle point and then you will get only OE. With that, you are drawing the circle. Here, later, what you have to do is fix the end of the rope at E, release the other end and then draw a circle. Similarly, you have to fix the one end at west point and then draw a circle. You get the intersection point, you have to draw the another diameter. Okay, that is anyway the north-south direction if you take this east-west. Okay, now after that, again you take the rope and fix here the middle point. You have to fix it at E. You draw a circle with the radius. You will get this one in this figure. Similarly, at north, south, and west, okay, you have to fix the middle point at this point, and then you will get the half of the chord, right? That with that rope, you have to draw a circle. You will get 4 different circles. Then join all the intersection points A, B, C, D. That's how you get the square. Okay. While drawing this, you will get this beautiful geometrical structure. Though the constructing square is easy, but you will get the beautiful structure along with that. There is one more method to construct a square where you have to have the knowledge of root 2. That is savishesha. That is the technical term for root 2. Okay. Again, I'll not go through the sutra, but I'll just tell in brief. You have to take a desired length AB, a rope AB. Draw the center line AB of length X here. You have to point the center. You have to mark a center. Take a chord of such a length that its 2 parts will be. See, earlier as I told that line, they were asked to divide the line into fractions, right? Here you have to divide x by 2 and x by root 2. Now, C is the midpoint of AB. Fasten the 2 points of the chord at A and C. You have to take a rope and you have to fix it at A and C with length x by 2. Whatever it is remaining, you stretch it. That will be x by root 2. You will you get the point D. So repeat the procedure by stretching the chord on north side also and repeat at B here at the bottom. The square of desired dimension is obtained. So this is how, there are different procedures to construct a square. So clearly you can see that AD is x by 2 and CD is x by half root 2. You will get AC square plus AD square is equal to CD square. In Apastamba, uses of 2 bamboo rods equal to 1 purusha and square root 2 purushas respectively for constructing a square, 1 square purusha in area. This is how it is done in order to get 1 square purusha in area. Now, these were the methods to construct squares. Let us see how to construct a trapezium. Trapezium, earlier we saw that how Mahavedi, the shape of the Mahavedi, that was in trapezium. Constructing of trapezium involves 3 inputs, that is face, base, and altitude. These 3 inputs are needed. In Sulbasutra, there are the names for trapezium is Ekato Animat, that means small at one end, and Purastad Amhiyasi, that means shorter in front. That is the term that they have used in Sulbasutra, Ekato Animat. So they have also given the area of trapezium. Now let us see the methods to construct trapezium. There are 2 methods employed. One is Ekarajva Viharanam, the method of construction with 1 chord. Another is Virajva Viharanam, the method of construction with 2 chords. I will just briefly go through it. Okay. Here, altitude is given 36 prakramas, or you can take even padas. Okay. Base 30 prakramas and face 24 prakramas here. How to construct this? Take a cord with 36 padas or prakramas, then add 18 padas to it. Mark at 12 and 15 padas. You have to take a rope and literally mark that. This is how they used to do. Fix, you have taken the now 36 plus 18 padas. You have to fix the end points at P and Q. Now, stretch along QC at mark 15. Okay. You will get, the rope is fixed at P and Q, and the length of rope where you have added 18 to 36 padas, you are stretching at the bottom. Okay. This is the rope. 15, 39 and 36. Similarly, you have to repeat at that side, another side. Again, take the rope, fix it at P and Q, but while doing at PB, you have to fix the pin at the mark 12 instead of 15 here. Here only one rajju has been taken, that's why it is called as ek rajju method. This is how the trapeziums are constructed. Only one rajju, but you are adding the length, and then see, you see here the right angle triangle, right? This is how they used to do. Even constructing the triangles, they used to have the same method. In Dvirajva Viharanam, using called twice actually. That means here, I will not go into detail, but here the triangles are constructed using rope once here and again once this side. Virajva Viharanam. Now coming to the another geometrical conversion of square into a circle while preserving areas. Here you are constructing, while we saw the Nitya Agnis. There you saw square, circle and semi-diagonal. That problem here it is dealt with. The sutra for converting a square into a circle goes like this. Chaturashram mandalam chikeshan akshnyardham madhyat prachim abhyapatayet yadyad atishishyate tasya saha tritiyena mandalam pariliket. So I'll just read out the translation. If you want to circle a square, you have a square, you can see here, A, B, C, D, you are converting that square into a circle. Okay. Draw its semi-diagonal, okay, OA, about the center towards the east-west line, that is OG. Okay. Whatever portion remains outside the square, with 1/3 of that, describe a circle. Okay. Whatever portion remains outside, that is OG. Okay. Let here AB, the length of AB is equal to 2h, then OA, obviously, that is h root 2. Now, IG, this one, IG is nothing but OG minus OI. That is h root 2 minus h. That is equal to h of root 2 minus 1. Now, here we have taken IH is equal to 1/3 of IG. Now, OH is OI plus HI. OH is OI plus HI. That is H plus 1/3 H of root 2 minus H. Here you can see the value of root 2. Though here I'm telling in the modern mathematical terms, but there in Sutra itself that was understood. Okay. And though they have not mentioned root 2 as such, and they have given the technical term called Savishesha, immediately after giving this sutra, interestingly, they give the sutra to construct root 2. Okay? The sutra goes like this: Pramanam tritiyena vardhayet tat chaturthena atma since they were dealing with rope is to be measured, okay, and should be increased by 1/3 of itself, which is increased by its 1/4 and diminished by 1/34 of that second increment. See, √2 is pramanam, okay, measure, it should be increased by 1/3 of itself, which is increased by 1/4 of 1/4 and diminished by 1/34 of that second increment. Okay. Though we are here, I have written in numericals, but actually in Sulbasutra, the rope is to be increased in fractions. Okay. That is how actually it is done. And the term, as I told, that is called as Savishesha. Interestingly, here the Savishesha, the term has been discussed by many commentators. Whether it is irrational or it is exact, this kind of discussions are given in commentaries on Sulbasutras. Coming back to this formula, here if we put, substitute the value of pi as 3.141593 and √2 as 1.412, we get the area equal to 4.0901, which is a bit more than the actual value. Okay. As we know that it cannot be exactly, you cannot convert circle to square or vice versa, because pi is irrational. So why this method have been used? Because it gives the closer approximation. And anyway, dividing the line into fraction was very common to Sulbasutrakaras. Now coming to Karanis, here, since I have just discussed about √2, that is called as Karani. Karani is the side of the square or the producer. But later mathematicians, they use the Karani Shabda for a third. Here, Shulba, though concept was primarily geometrical, it was used to denote the root of any number. This Karani was used to denote any number like Dvikarani, Trikarani, Chatuskarani, like that. The knowledge of determining square root of figures was developed to high degree, because you can see this determining square roots of whether square root of 2 or 3 or 5. You can see such sutras for these Karanis. Later, the Karanis was called as Mula. Later mathematicians. Let us check on irrationality of 2. Baudhayana Shulbasutra, Apastamba, Katyayana gave the value of √2 with an additional term called Vishesha. Now, many scholars express the doubt whether the term Vishesha expressed irrationality of 2 or not. The commentator Karavinda Swami, who was around 12th, 13th century, in his commentary says that the root cis, when prefixed with V, denotes in all cases a correction in excess. That's what he means. That's what he comments on the term Vishesha. The same meaning is taken in many Jaina works also, in the same sense. Now, I'll just give you the sutra to find out √3. So after soon after √2, they give the value how to find out the √3 on of course on a rope. Pramanam tiryak dvikaranyamaha tasyakshnaya rajjustrikarani. One should get the breadth equal to the measure of square and length equal to the diagonal of that square. Then diagonal of such an oblong will produce an area equal to 3 times area produced by the side of the square. This diagonal is called Trikarani. You can see here A, B, C, D with the side A. Then the diagonal is A √2. Okay. Then you have to construct a rectangle whose side is A √2 and the side A. Obviously, the diagonal will be A √3. Here you will get the value of √3. If you measure it, definitely you will get the value of √3. There are people, scholars, historians, they try to give proof for this √2 value. Like many scholars like Datta, Taibhot have provided proof for sutra of √2. Datta's proof is geometrical, But Taibo chooses the arbitrary relation 17 square is equal to 2 into 12 square to provide proof which leads to the origin of the formula of root 2. He got the inspiration from Bodha in a selection of units 12 angulas and 34 tilas. So he argued by how much the side 17 must be diminished in order that the square on it may be 2 into 12 exactly. This is how the German Indologist Taibo gives the proof. They tried to give different different proofs for root 2. So if we see one, we have now already converted square to circle, and similarly, if you see how this circle is converted into square. Okay? The sutra goes like this: Mandalam Chaturashram Chikishan Vishkambhashto Bhagan. This is how it goes. That means if you wish to convert a circle into a square, one should divide the diameter into 8 parts and divide one of these parts again into 29 parts and subtract 28 of this, 20, that is 29th part together with 1/6 of one of these parts. The later being diminished by 1/8 of that is the that is the side of the square. If you convert it into modern terms, you get A is equal to D into this term. Okay. Now, substituting the pi value, taking 3.1415 and calculating it, you will get the side as 0.983045, which is little less than the correct value, which is 1. There are commentators like Dwarakanath Ejwa and all. They have improvised these techniques and come up with their own corrections. He gets the pi value as this with correction. Sir? So I'll just is it the time is over or
It's kind of little over, but how much time do you need more, Vanishri?
yeah, and I think I'll discuss 2 of them and then come
Yeah.
to the conclusion,
Yeah,
because I
that
think
should
these are little 3 of them actually.
no
There are
worries.
some examples. Okay,
Yeah.
now you are, because it is a constructive geometry, you are constructing something. There are different constructions. Here is a small example where you have to convert a rectangle ABCD into a square. Okay? Here ABCD is given, and this AB1 is to be cut off. The remaining BB1 is to be divided into 2 parts. You have to take this part and fix it here. Okay. Now join AB2, C2, D1. Now this small portion is remaining. Okay. That portion, how to remove the portion, square. This is the square. Square from a square is given. So geometrically given. Say a square minus b square. Okay. This is a kind of, if you tell it algebraically, that is a square minus b square. How it is done? See, I'm not reading the sutra. Let ABCD be the square. Okay. Now, AE be the side of the square to be removed. This one. The segment AEFD is cut off. AD is drawn diagonally across with A fixed till this diagonally you have to draw it till it reaches the P. Then EP is the side of the EP. You can see EP is the side of the required side deducted from the AD. Okay. EP square is nothing but this EP square is nothing but AD square minus A square. So the algebraical thing, A square minus B square, that is also shown geometrically. I will not take that one, but I think this is one is interesting and ingenious method to construct a square, n number of squares. You have to add all number of squares into a one square. यावत् प्रमाणानि समचतुरस्रान् एकीकर्तुं चिकीर्षेत् एकोनानि तानि भवन्ति तिर्यक् द्विगुणान्येकत एकाधिकानि त्र्यस्यर्भवति तस्य इषु तत्करोति. the yavat pramanani, how much ever numbers of squares that you are going to combine. Okay? What you have to do is you have to construct isosceles triangles. Okay? Take AB plus AC as n plus 1A. Okay? N is the number of squares that we are going to combine. BC is n minus A. Just simply you draw this isosceles triangle, and the arrow AD will give you the side of square which is equal to the n number of squares that you have taken. Okay, simply you don't have to remember any formula or anything. Just you construct the square like this. That's all. I think this is an ingenious method that's given in Sulbasutra. Again, I'll not discuss. I'll just briefly go through the geometrical procedures briefly, not deep in detail. Okay. Theorem of squares of diagonals, that is so-called Pythagorean theorem, where in India they don't take a triangle as such, but it is discussed with rectangle. Okay. That is, anyway, it is simple, and obviously it can be understood by the diagram itself. Proof, okay. Proof, whether the proof was given. No, though the proof was not given, but when you go through Sulbasutras, you will understand that it is obvious. It is obvious that they knew the proof, and it was not required to prove, because Indian geometry is not it is not like axioms and theorems and proofs. It has a different purpose. Just to construct Vedis, you need some geometrical purpose, and that was given. Proof was understood. Okay. And you see, there are rational right angle triangles, and there are different examples which have been given in Sulbasutras. These are all some of the rational right angle triangles. Okay, I'll just come to the conclusion. I hope I have covered, this is a vast area, but still I hope I have given you the overview of Sulbasutras, okay, how constructive it is. So we know that it's quite clear that Sulbasutrakaras were using sophisticated and interesting geometry in order to meet the accuracy of construction, because as I told that shapes should be precise, they should be accurate as ordained in Vedas. Okay. This mathematical development happened because it was necessary for religious practices and observance. Okay. So Vedic sacrifice had developed as the science of geometry to a remarkable extent. The most important achievements in Shulba geometry is the enunciation of theorem of the square of the diagonal, and understanding the properties of similar figures. If you go through Sulbasutra, that is evident. Though the manuals are estimated to be written around 800 BC, but you can tell that it existed before Veda came into existence. The last but the least, it's actually my concern. Okay? Since most of the works are buried in commentaries, okay? It's important and imperative as on to take initiative to bring forth the contents of them in the light of modern mathematical language now. Thank you. I think I conclude with Dhanyavada. Sorry, I have taken a very long time.
No. This was, I mean, we could continue forever and gain from your wisdom, Vanishri. But unfortunately, again, the time is a concern. But I'll pass it on to James and then Raghvendra to kind of talk about the talk.
It's fascinating. Thank you, Vanishri. It's a fascinating area, and it's very interesting to note that they used what we call the Pythagorean theorem. Obviously, in India was known about much earlier. And in fact, Pythagoras himself, I mean, we've named the theorem after Pythagoras, but he probably discovered it or certainly came across it in Egypt on his travels, there is some evidence to suggest that Pythagoras himself traveled to India, but we don't know. But clearly, having those Pythagorean triples expressed in the Sulbasutras, and the fact that the Sulbasutras are probably much, much older than 800 BCE. It's very, yeah, it's good to hear. And those I particularly like doing the constructions with a piece of rope and bamboo sticks. It makes me feel that I want to get a piece of rope and try it out myself. So
I mean, still there are people, I mean, who have preserved this knowledge in small areas, and they actually, I heard, they use bamboos and ropes in order to construct Vedis.
Very good. Thank you very much. Thank you. Raghavendra.
Yeah. So good evening. Really, Dr. Vanishri Bhat, you have taken a very interesting topic of constructive geometry in ancient India. I'm going to give a brief of what are the key points which have given the insights for us, so that we can explore a lot in this particular direction. And you have started with quotes from Vedas and performing yagnas. And what are the different types of yagnas? Grihya, Shrauta, Havir and Soma and Rashtriya, and also what is the importance of doing such yagnas for personal purpose as well as the purpose of the nation, and different types of knowledge. And also in the Veda, what is called as Para and Apara Veda also you have covered. And particularly you have taken the Sulbasutras, and also you have described what are the different parts in this Vedas, and in that particularly Kalpa, and in that Sulbasutra, Shulba means a measure, and you have detailed about what is Rajju, that is the rope, how the measurement is going to take place, and we can measure using ropes, which is very, very interesting. And also, and different types of Agnis, like Nitya and Kamya, and also how the perfect construction was done, and what was the importance of sacrificial altar. And particularly you have shown the actual circular and semicircular and also square shapes altars which were used, and how perfectly these were constructed using this knowledge, and how the knowledge was built, and altars, and also what are the general uses of that, that is the prayojanas. 10 of them you have explained and also given an insight, and how different chittis were there, and what is Shulva Sutra, and also Bodhayana particularly you have mentioned, and 800 BC and beyond that, and it is known to Indian, and also they are how they constructed. And particularly you explored a lot in the geometrical knowledge in Vedic period, and variety of chariots, concentric circles, and terms like Atharva, in the Atharva Veda, what is the familiarity of fractions, operations and fractions, and measuring instrument is Rajju, Shanku and Venu, and also Shamya. You have given the insight, and you have literally explained about how do you construct a square, how do you construct a circle, and all these like east, west, north, the north, south line, how you are going to construct, and construction of various geometrical shapes like square, trapezium, and all, and Karani, and finally it came to what is called as, finally it is resulted in what is called as irrational numbers, and how do you calculate root 2, root 3, and different things, and also, and ended into rational and also right angle triangle construction. So which has given a very great insight into using very, very simplistic methods of Rajju and all, how the construction used to be almost very near to the perfection. It was mentioned in the ancient Indian history also. Really it was very, very interesting, and also we need much more time to again, like as James said, like we have to try out using the threads, and also we try to construct how they were able to do it in a very great way, to an extent of almost approximation it was done. Really you made it very interesting for us, and we are given an insight in a way such that we are also going to explore, who are very much interested in geometry and all. Thank you, ma'am, for giving your time, and also you have shared your experience and also knowledge with us, and you have encouraged us to go in this particular direction. Thank you.
Thank you. Thank you for giving this great opportunity.
Yeah, thank you again. And there are a few comments which I would like to read. Prajakti says it's a beautiful topic with in-depth research. Need to have another session soon. I think this is what everybody is saying. You need to teach us more or talk about it more. Ekta Sachdev says, lovely topic. Would like to stay connected and stay inspired. Yogita Mishra, thanks for this webinar. And Chaitra Ji, Namaste Vanashri ma'am and IIBM team. Interesting topic and great presentation. You made it very simple and engaging with the diagrams. Look forward for more such workshops. Thank you, IIBM, for hosting. Thank you, ma'am. Thank you again so much. We have, I'm going to 1 minute, stop the recording so that